Okay, so previously we did solving systems using graphing. And graphing is a fine method, but it's not the best. It takes a while. It's a little time consuming. The other big issue with graphing is that, what if your intersection point is between two integers? What if it's between 1 and 2? If it's between 1 and 2, you don't know for certain if it's 1.5. It could be 1.6, it could be 1.4. It's hard to tell if it's not an integer. So there are other methods that we use, and usually better methods that we use. So we did the graphical method. There's two algebraic methods. So we're going to do the first one today. Okay. So the first algebraic method is called substitution. Okay, substitution method. Substitution method always works for every single system. So this is a method that can always work. It doesn't matter how the system is set up. So it always works for any system. So again, this is the first algebraic method. All the algebraic methods work for any system. When do you want to use substitution? You want to use it, you could use it any time, but the best time to use substitution is when one of the variables is already isolated. So we're going to say use when one variable is isolated. And that's going to come up again in the steps. Alright, and then like I said, this is the first of two algebraic methods. We'll just write that down, that this is one of the algebraic methods. We'll call it number one, it's the first one, first of two. Alright, so let's talk about the steps for substitution. As the name suggests, the substitution method uses the substitution property, which is one of the properties we talked about at the beginning of the year. So the first step in substitution is to kind of use what we wrote down here. Okay? Use when one variable is isolated. That's the first step as well. Not every problem is going to have a variable isolated, so your first step is to make that variable be isolated. So we're going to say we're going to solve one equation for one variable. Solve one equation for one variable. Alright, so what does that mean? It means you need to see one of your equations, because remember our system has a top equation and a bottom equation. You need to see one of your equations be in the form x equals or y equals, okay, depending on which variable you pick. Now a lot of times that first step is going to be solved for. If it's in y equals, it's probably in slope-intercept form. It could also be in x equals form. So as long as you have one variable equals some algebraic expression. Alright, so what are you going to do with that one equation solved for one variable? Okay. This is the first substitution. You're going to substitute the step one part. So substitute the expression from step one. Substitute the expression from step one into the other equation. So you're going to be working, step one, you're working with the top equation or the bottom equation. Whichever equation you didn't use is what you're going to be plugging into. So substitute the expression from step one into the other equation. Alright, step three. Step three is you're going to have one equation now with only one variable. When you have one equation with one variable, we can solve those. Okay, we don't know how to solve equations with two variables, but after step two, you're going to have just one equation with one variable, and we are going to be able to solve that. So in step three, you're going to simplify and solve the equation from step two. Simplify and solve the equation from step two. Alright, so at this point, after step three, you're going to know one of the variables. So at this point, you're going to know either x or y. But remember, the solution to a system is x and y. It's that ordered pair. It's the point where these two lines intersect. So just because you know what x equals or you know what y equals doesn't mean you're done. It means you're only halfway done. You still have to find the other variable. So after step 3 will be step 4, where you find the other variable. In substitution, you're going to have a second substitution. So step 4, you're going to substitute the value from step 3. Substitute the value from step 3 into either equation. So remember, you have two equations to choose from. You could choose the top equation or the bottom equation. You're going to substitute the value from step 3. It's going to be x equals a number or y equals a number. And you're going to substitute that back into either equation. And then use that to find the last variable. Okay. So if you found x in step 3, you're going to be finding y in step 4, and vice versa. So that looks like a lot of work. It's really not that bad. When you start doing examples, you could kind of skip some of these steps. Okay. So let's look at the first example. Alright, so I got a system here. Top equation is x equals 10 minus y. The bottom equation is 5x minus y equals 2. Okay. Well, let's just run through the steps. Step 1 was to isolate one variable, or substitute one variable in one of the equations. Well, step 1's already done for us. Step 1 is already done because the top equation is x equals. Okay. Anytime you have x equals or y equals, that means that variable is already isolated. So step 1's done. So the part we need for step 1 is just that top equation, x equals 10 minus y. Okay. So we move on to step 2. Step 2 was to substitute the expression from step 1 into the other equation. So we use the top equation for step 1, which means we're going to use the bottom equation in step 2. Now all we're going to do is, because x equals 10 minus y, we could replace x, anywhere we see x, we could replace it with 10 minus y, which is what we're going to do. So we're going to take this 10 minus y and we're going to just plug it in, substitute it in for x. So instead of 5x minus y equals 2, we're going to have everything staying the same except for x. We're going to replace x with 10 minus y because that's what x equals. So we're going to have 5 times 10 minus y equals 2. Okay. So now again, notice we started with an equation with two variables. We had x's and y. Now in step 2, we have one equation with one variable. There's no more x's in this equation. There's only y's. Okay. So then you move on to step 3, which is to simplify that equation and then solve for the variable. So the variable we have is y, so we're going to be solving for y. Okay. And to do that, you just use, whatever you see. In this problem, I'm going to have to distribute. We're going to have to distribute the 5. So we got 5 times 10, which is 50. We got 5 times negative y, which is negative 5y. Don't distribute to that y, but it's still there. Equals 2. Actually, I'm going to keep that in black just for continuity. So it's going to stay minus y equals 2. And again, just step by step, simplify and solve. What can I do from here? Well, I can combine like terms because I have y and y. 5y minus y is negative 6y. The 50 stays, equals 2. Okay. All right, and then this is just a two-step equation. Add or subtract, multiply or divide. So let's see, we can subtract the 50 on both sides. It leaves you with negative 6y equals negative 48. And then solve for y, divide negative 6 on both sides. And we're left with y equals negative 48 divided by negative 6 is 8. So y equals 8. All right. Now again, that's not our answer. That's part of our answer. So since it's not our full answer, I like to put a dotted box around it. Like, we're going to need this later, but we don't need it right now. It's not our answer, but we will need it to find the rest of the answer. Okay. So we got our first 3 steps. It's kind of a lot of work. Luckily, step 4 is pretty easy. Step 4, we're taking our answer from step 3 which was y equals 8. And we're going to plug it in to either one of these equations, either one of the original equations. So you could do the original top, or you could use the original bottom. It doesn't matter which one you use, because remember, the solution has to satisfy both equations. So I'm going to use the top equation. So the top equation tells me that x equals 10 minus y. Well, the good news is now we know what y is. Y is 8. So we're going to take this 8, and we're going to plug it in to y. So that's our second substitution. So instead of x equals 10 minus y, we're going to say x equals 10 minus 8. So x equals 10 minus 8. 10 minus 8 is 2. So x equals 2. That's the second half of our answer. All right, and when we solve a system, we always write our answers as ordered pairs. So the solution to the system is x comma y, 2 comma 8. So that one was kind of easy, or it was the easier version of substitution because step 1 was already done for us. What if step 1 isn't done for us? Well, you could still use substitution even if one of your equations isn't isolated. So let's look at an example like that. Okay, so in this example we got top equation negative 3x plus y equals negative 2. Bottom equation x minus y equals 4. Okay. Well, none of those variables are isolated. So we have to do step 1. Okay, in the first problem we didn't have to do step 1 because there's already an x equals. This one doesn't have that. Okay. So we have to pick one of these variables to isolate it. It doesn't matter if you pick a top equation, doesn't matter if you use the bottom equation, you can pick any of the variables. Usually which one you want to pick is you want to pick whichever one doesn't have a number in front. So like we wouldn't pick negative 3x, we don't want to isolate that because it's a lot of work. So the best one to isolate here is, I'm going to isolate this y value. Okay. I'm going to get that y value by itself. Okay. How can I get that y value by itself? Well, if you have negative 3x plus y equals negative 2 and you want to get just y, we're going to have to add this 3x to the other side. Okay. That's going to cross out. And now what we have is we have y by itself on the left side equals negative 2 plus 3x. I'm just going to leave it like that. Okay. So that's my step 1. I got one variable isolated from the top equation. Okay. Now what do I do with that variable? What we're going to do is we're going to substitute it in. I now know that y, wherever I see y in any of these equations in the system, I could replace it with negative 2 plus 3x. So in the bottom equation, I'm going to substitute that in. I'm going to plug in, instead of x minus y, I'm going to have x minus negative 2 plus 3x. So I'm just going to rewrite that bottom equation for step 2. Okay. Again, instead of x minus y, I know I'm saying that y equals negative 2 plus 3x. So we're going to say x minus negative 2 plus 3x equals 4. Okay. So now step 2, notice that this equation only has x values in it. If it only has x values, we could solve that. Okay. This one's a little weird with the solving because you do have to distribute the negative sign. When we did the distributive property, we talked about this a little bit. You do have to distribute the negative sign into the parentheses. So when we distribute, it'll be x minus, so negative times negative is going to give us plus 2 minus 3x equals 4. And we're going to solve that equation. Okay. First thing I would do here is I would combine like terms. I have a 1x and a negative 3x. So when I combine them, since they're on the same side, 1 and negative 3 combines to give you negative 2. So I got negative 2x plus this constant 2 equals 4. And again, this is just a two-step equation. So add or subtract, in this case, subtract 2, gives you negative 2x equals 2, and then divide both sides by negative 2. So I now know what one of the variables is. I know one of the variables, x equals negative 1. Okay. Again, not our answer, but we're going to need it to get the rest of our answer. So I put a dotted box. Alright, so now I know what x is. If I know what x is, I can go back to any of these equations. So I have three options to choose from. I could plug in, since I know x is negative 1, I could plug it in anywhere. So you could plug it in to the original top equation, it's option A. You could plug it into the original bottom equation, option B, or you could plug it into the new top equation, which is option C. Now usually this is the one you want to use in substitution because it's, you have to do the least amount of work. So I'm going to use option C, which was y equals negative 2 plus 3x. Right, so I didn't number it. This was step 3. Simplify and solve. And then step 4 is I'm going to substitute this value, x equals negative 1, into this equation for x. So in step 4, I'll do it off to the side. I'm going to use the equation y equals negative 2 plus 3x. And I'm going to sub it in for x. Okay. So instead of 3x, I'm going to do 3 times negative 1. So it's going to be y equals negative 2 plus 3 times negative 1. And just simplify. Negative 2, 3 times negative 1 is negative 3. Negative 2 minus 3 is negative 5. So that is my y value. So I know x, I know y, just write it as an ordered pair. So x comma y, negative 1, comma, should be negative 5. Okay. So those are the two main types of substitution. One where step 1's done for you, so it's just written in a form where x equals or y equals a part of the equation, and then one where you have to force one of the variables to be isolated. But again, the steps are all the same. You want to get one variable, x equals or y equals by itself. You're going to substitute that into the other equation. Simplify and solve. After step 3, you're going to know one of the variables. You just plug that variable back in to find the other missing variable.